In this session, we're going to discuss how or why men gets electric shock. Now, this is the continuation of the previous session. Now, men gets electric shock when there is the difference in the potential difference, or when there's a difference in the voltage level. If you consider this example, now often we see that birds are not getting electric shock even if they're like resting in the high in a live conductor. So consider that this is the 11 kV line and then the bird is resting here. Why that bird is not getting electric shock? If you look into this, so if this is R phase, okay, if this is R phase, and then if it's Y phase, and then it's V phase, the bird is resting only in the R phase. Like its two feet are on the same line, and remember that it's on the 11 kV line, which means there's no potential difference between its two legs. Similarly, we can also hang from the live conductor, provided our legs are in the air from the ground. But remember that we should maintain enough space from the leg and the ground. We get electric shock when we touch the live conductor and then any part of our body is touching to the ground. During that time, there's a flow of electric current from higher potential to the lower potential. In that way, we are getting the electric shock. Now, to get the electric shock, it also depends upon the like to get the electric shock. It depends upon the completion of the circuit. Now, circuit completes when our body is touching on the two different levels of the voltage. In example that I've shown is like one of the our body part is touching to the live conductor and then other part is touching to the ground. During that time, there's a flow of current. Now, the amount of the current flow depends upon the resistivity of the conductor, the resistance of the conductor. Now, this can be explained with the help of the flow of water and the size of the pipe. If the diameter of the pipe is large, then water will flow easily. Similarly, current also flows easily for the larger cross-sectional wires. Now, this is the main reason why we have R pin bigger in area. So if you compare with other two pin here, this one is bigger in the size. The reason is when the area cross-sectional area is big, your R value decreases. Is given by this expression. When the R value decreases, the current, if there's like electric fault in a system, it easily discharges from this conductor. Now the next terminology is the voltage. Now the voltage, we also call it as a potential difference, or it's the force. It's a force to move the required to move the electrons in the conductor in a particular direction. It says that to move that electron in a conductor in a particular direction, some external source is required. Now this external source, we call it as a potential difference or the voltage. The driving force of electrical current between the 2 points. Now if you consider this figure here, we have point A and point B. If you measure the voltage from point A with respect to point B, we'll have the magnitude VAB. Similarly, we can also measure from point B to point A. Now, in a fast measurement, when you measure from point A to B, if you consider point A as higher potential, and then when you measure the voltage across this resistor, we have the magnitude VAB, and we can also measure the voltage from the lower potential to the higher potential, which is given by VBA. Now, during that time, we can have the same magnitude, but remember that we will have the negative sign in our measurement. Now, this negative sign indicates that we are measuring from the lower potential to higher potential. Now, In our module, whenever we are analyzing the circuit, we have to take note that we're often defining our voltage with respect to the ground voltage. Now, ground voltage, we consider it as a 0 volt. In a circuit, voltage is often defined with respect to the ground. Remember this. The voltage across an element is the work or the energy required to move a unit positive charge from the negative terminal to the positive terminal. Now this, I think if you have understood the previous slides, this is another way of interpreting the voltage. It's given by W by Q, and W, the unit of the energy is joule and unit of charge is coulomb. This joule by coulomb is called the volt, and here also there's a explanation of the volt, so you can read it yourself. The next is the power. The rate at which energy is converted or work is performed is called the power. Now the unit of the power is watt. Now watt is the result of 1 joule of energy converted or used in 1 second. Now this is called the watt. This is called the watt. Watt is the unit of the power. Now to measure the power, now when you say of the power, it is something talking about a certain a specific point of time. For example, at 5 p.m. if you're measuring the current and the voltage at 5 p.m., we're taking exactly at that point. And then there's a difference between the energy and the power. So when we are recording the current and the voltage at 5 p.m., exactly at 5 p.m., we are measuring the instantaneous voltage and the current. Now, if we multiply voltage and the current, then we get the power, which means the power is the rate of doing work at a particular point of time. We're not considering up the time duration. We're taking at instantaneous time, like instantaneous point. Now, when you talk about energy, I think you will understand what's meant by power and what's meant by energy. So we can compare energy and the power. Okay, let's look into the energy first. So electrical energy introduced the concept of time to electric power. Now, to measure the energy, we have to consider the time duration. Now, for the power, we are taking at that point of time, but for the energy, we have to take certain duration. Now, to measure the energy, we can say that if you're measuring the current and voltage from 5 p.m. to 6 p.m., then we're taking the duration of 1 hour. So during that time, from that 1 hour times the current and voltage will give you the energy. But for the power, it's like only voltage times current. Remember this thing. Now this is the difference between the power and the energy. Now in our day-to-day life, you're using the electricity. So in the electric bill, are you paying for the power or for the energy? Now here is the question. In electric bill, are you paying for the power or for the energy? So please think over this. And then this energy can be explained. This energy and power can be explained through the water flow analogy. It would be the volume of the water flowing through the pipe at a given time. Now, if it is power, it is the combination of the water pressure, the voltage, water pressure which is compared with the voltage, and then the rate of flow, the current that results in the ability to do work. Which means for the power, we are not measuring the volume. For the power, if you compare it with the water flow analogy, we are not measuring the volume, but we are just comparing like how fast that water is flowing through that pipe. But for the energy, we are measuring the volume, how much water is being followed through the collected in that container in a certain in a given period of time. Now this is the energy. Okay, other electrical terms can be related with the water flow analogy. Okay, this is like as I explained in the previous slides. So you can also think over this. The pressure or the height of the water tank is the force, right? Force which can be compared with the voltage or the potential difference. the hose or the diameter of the pipe, which can be compared as the resistance, and then water flow inside the hose, which can be compared with the electric current. Now, in the next session, we're going to look into the electric circuit. Now, in the electric circuit, we're going to discuss about the electrical elements in a closed path. Okay, we have okay. Anyway, we're going to discuss in the next slides.